Okay, we're ready to roll. All right, let's first we got to review Pythagorean theorem. This can only be used in a right triangle, remember? Anything we use today, by the way, can only be used in a right triangle. You can't just use it whenever you want. Pythagorean theorem, a squared plus b squared equals c squared. And just a reminder what a, b, and c mean. So if you just draw yourself a quick sketch of a right triangle, anybody remember what the a and b are? What they call the legs, which make up the right angle. There's A and B, and then C is what we call hypotenuse. I know people always say it's the longest side. I don't like that. It's the side across from the right angle. Okay, it's always the side across from the right angle. All right, so here we go. In right triangle ABC. So that's how I name it. Everyone sees the right angles at C. So plop, boom, right away. There's my right angle C, so that means A and B are the other two. Doesn't matter. Nope. All right, doesn't matter where A and B are. All right, how about the side lengths? AC is 2 and BC is 3. Find AB in simplest radical form, so we're looking for AB. All right, ready for a little Pythag. A squared plus B squared equals C squared. Where should the 2 and the 3 go here? A, everyone all right? It's going to go in for A and B. 2 squared plus 3 squared equals C squared, or X if you have an X there. All right. All right, you're ready to pick up those numworks calculators. I know some of you could probably do this without it, but remember you have an equation solver on there, and it'll solve this equation, so I'll go with you. All right, so over to the equation solver. Add an equation. What do we have? 2 squared. So 2 squared plus, what was it, 3? 3 squared. And the reminder where the equals button is. The equals button is where the pi is. Yep, the squared, good, sorry. The squared is above the parenthesis, right-hand side. Yep. And then the equals is where the pi is, but you got to go shift pi. Now you could put x squared here. All right, you could put c squared. It's up to you. All right, it'll tell you either way. So I'll just keep with x because the button's right there. Equal to x squared. Everyone's all good. And then execute exe, so it's highlighted in gray and it's in there. And now I go down to solve the equation at the bottom. And it'll give me both values. No? It doesn't give you that? Everyone's getting that? Okay, here's the one thing, though, you got to be aware of, right? We're talking about a side of a triangle. So do I want to write down negative radical 13 and radical 13? No, I'm only dealing with what? The positive one, right? Which is square root of 13. Yeah, don't bother with this down here. That's we're just looking for the two. There's two. The calculator is showing you two answers. All right, negative radical 13, which doesn't make any sense because it's a side, and then positive radical 13. All right, so C equals radical 13. Now look, could I have gotten that by just doing 4 plus 9 equals C squared and then taking the square root? Yes, but your calculator will always give you the answer in simplest radical form, so you don't have to do any extra work. All right, it'll always give you the answer in simplest radical form. Questions? All right, let's keep going. How about Laura in her backyard? It's in the shape of a rectangle. Beautiful. Put my rectangle up. And the backyard is 12 by 15. So one side's 12. The other non-opposite side, 15. Or switch them if you want. Oh, this is cute. She's going to put rock wallway on the diagonal. How long will this walkway be? There we go. So everyone see the Pythagorean theorem now. 12 squared plus 15 squared equals C squared. And again, I'm going to give you guys options. I don't care. I'm just showing you maybe a little easier way. You don't have to worry about computation. All right. Can you go 12 squared to 15 squared and then take the square root? You can. Can you go to the solver on numworks? Yes, you can. It's up to you guys. I have to round my answer to the nearest foot here, though. All right. Round my answer to the nearest foot. So however you're going to do this. And if you're using the numworks, obviously we don't want the negative answer because I'm doing a sideline. And what are we getting? 19.2? Looks good. You guys are going to love these calculators even more. Next problem.
Wait.
What?
I got 3 and then 41 square.
3 root
41.
Okay, yeah, but that's, yes, Gabby, if I said in the directions, leave your answer in simplest radical form, give me that. But the directions say
I see,
nearest
it's
10.
right there.
I'm glad you did that. All right. If it said simplest radical form, yes, I want that 3 radical 41.
Oh, I see.
Okay, but since it said nearest 10th, I'll take the decimal instead.
Gotcha.
Yeah. Yeah, what's up, stud?
What's that number on the bottom?
That is that b squared minus.
Yeah.
It's something to do with the quadratic formula. Don't worry about it. Okay, you stay right in your lane. All right. Yes.
I'm getting like X40. It was on the last one too. It's just like it's like a saying.
Less of that. Still good.
Why?
I don't ignore it, predefine. I don't know.
Okay.
All right, yeah, don't worry about it.
All right.
Okay, everyone good? All right, wait till this now. You're gonna love this now. All right, one more Pythag question. All right, it's a right triangle. I know 3 sides. Done. Pythagorean theorem. All right, as long as I'm dealing with all 3 sides. All right, first question is, what's going to go in for A, B, and C here? Where are my 2 legs in this diagram? X. So I'll stick with 8 squared, and then plus x minus 4 all squared. Make sure you squaring the whole thing and not the 4. Equals, what's my hypotenuse across from the right angle? X squared, right? And I'd love to tell you we need to go further, but we don't. Gone are the days of trying to do this because I'd have to do x minus 4 times itself and keep going here, but grab those numworks calculators and solve it. Yeah, how about that, huh? Yeah. Nope. But again, the numworks calculator is great, don't get me wrong, but you have to set this up, though, correctly to use it. What are we getting for x? 10, right? You're killing me over here.
I'm.
Okay, you gotta put that in parentheses. Because if you don't, Gabby, the calculator's thinking you're just squaring 4.
Okay.
So you gotta square the whole thing, so that needs to go in parentheses.
Okay.
Okay? Good mistake, though. Anybody else here? Using Pythagorean theorem. Going. So it's nice when I can just plug it in the calculator and let it do the work. Brain trust all right back there? You guys good?
Yeah.
Okay. All right, so there's Pythag. Now to come to a harder topic you did in your 10th grade year. The special right triangles, which is 45, 45, 90, which we'll start with that one first. Okay? So it's a right triangle where both angles are 45 degrees. So I want to review with you guys the rules. Okay, how to find the sides. Remember, these are called your legs, right? Do you see that they're across from, both legs are across from an angle of 45?
Yeah.
So because they're across from the same degree measure, that makes them
Equals.
the same. Both legs are equal. Okay, so whatever is across from 1 is the same as the cross. So if 6 is here, this other side is 6. All right. Now, how do you find the hypotenuse? How do I find the hypotenuse here? Okay. The hypotenuse, now could I do Pythag? You could. The hypotenuse is going to be whatever the leg is. Anybody remember back in the day? Times, this would be ridiculous if you did, but square root of 2. Okay, so I multiply it by the square root of 2. That's for a 45, 45. The legs are always the same value. The hypotenuse you get by taking a leg and multiplying it by radical 2. And these are not anything I'm going to give you for when we take the quiz. So that was one special type. The other special type is if the two other angles are 30 and 60. 30, 60, 90. So do you think the two legs are going to be the same here? No, right? They're 2 different degrees. But I will have a smaller leg and a longer leg. How do I know where each is? What's the smaller angle? 30. So guess what's across from the 30? Smaller leg. And what's across from the 60, no matter where it is? That's my longer leg. All right, please don't just assume it's on the left. Wherever the 60 is, look across, and that's the longer of the 2 legs. And then we still have the hypotenuse here. So let me go over the 2 rules, how to find the sides now. Let me start with the longer leg. I'll just abbreviate it LL so I have space here. How do I find the side across from 60? The longer leg. That's your shorter leg, SL, times, anybody remember that one? Not going to waste time. Radical 3. Okay, so I take whatever the shorter leg is and multiply it by radical 3. And this will make sense when we do a problem here with numbers. What else do I need to tell you? How to find the hypotenuse? Double the shorter leg. 2 times shorter leg. Okay, 2 times shorter leg. All right, let's try one out here. Right triangle ABC. C is my right angle. A and B can go anywhere. Angle A is, everyone's comfortable putting angle A is 30, meaning what's angle B then?
60.
Everyone 60? All right, so I got to remember now my 30, 60, 90 rules we just wrote down. BC is a length of 8. Forgot to put the C in there. Everyone's good? BC 8. Find AB. What's AB again? Is that a leg, shorter, longer leg, or the hypotenuse AB? Hypotenuse. So I'm going to write, all right, I know the rule. The hypotenuse equals, look above. How do you find the hypotenuse? 2 times the shorter leg. This is why it's so important to know what each piece represents. All right, so the hypotenuse is 2 times, where's this 8 across from? Where's the 8 across from?
30.
The 30. So would that be the shorter or the longer? Shorter, which is what I need. So the hypotenuse is going to be 2 times 8. Does everyone see how I know 8's the shorter leg? It's across from the 30. So the hypotenuse, 16. Stop me here. We all right? Because I got to make sure you guys have a chance to practice on delta math. Ladder leans against the wall. Great. You know what? Anytime a ladder leans against the wall, it's a darn right triangle. All right. If you want to make a cute little artsy picture of a ladder up against the wall, feel free. I don't want to embarrass myself, so that's why I just drew the right triangle. Makes it up against the wall at a 45-degree angle. So here's my ladder up against the wall. So if that angle's 45, what do I know about the other? Also, this is a 45, 45, 90. The ladder's 12 feet long. Where's the 12 going now? Yeah, right? Because the ladder's the one leaning against the wall. So I'm going to put the 12 here. How far up the ladder does the ladder reach, huh? How far up the wall? Does it really, does it matter what side you find? Why? They're both the same, all right? So even if you mess up what side is actually the ladder up on the wall, it doesn't matter. All right. Remind me again, what's the 12? Hypotenuse. Don't I have a formula for the hypotenuse? Hypotenuse equals, how do you find the hypotenuse in a 45, 45, 90? Leg times radical 2. So all I'm doing with you guys is writing out the rule. Plug something in for the hypotenuse. 12, right? Equals, what did we just label the leg as? X times radical 2. Now use your algebra knowledge. Oh, no, oh. What's happening between the x and the radical 2? Multiplying, right? So how do I get rid of the radical 2? Oh, you guys are making it too hard on yourselves. It's being multiplied. So how do I get rid of the radical 2? Divide both sides by radical 2.
When it comes out as a decimal, what do you round to?
Whoa, whoa, whoa. Whoa, whoa. This says final answer in simplest radical form. We're going to the wrong calculator right now there, kids. Hey, look, remember, this isn't going to get you simplest radical form. All right? The numworks calculator will get it. So now, hey, we don't need equation anymore. Take a look, because we're not solving an equation. All I want to know is what is 2 divided by radical 2. So instead, go hit your home button. And now I just want to go over to calculation. That's to do your adding, multiplying, subtraction, etc. I don't need to solve an equation here. I just want to know what 12 over radical 2 is. So 12 divided by, and then everyone see where the radical is? Right above the parenthesis, radical 2. And look at that, it'll do it for me. 6 radical 2. Okay? And this is why I'm having you use those calculators. I don't know, do you remember last year in Algebra 2, you can't have a radical in the denominator. You got to multiply top and bottom by radical 2. It's a pain in the butt. We'll do it for you now. Okay? We'll do it for you. Before I move on, was anybody going to do this because you could do this a different way. And you guys have proven to me this year you can handle this. That's x. What's across from the other one? They're both the same. Can I do Pythag now? Could I do Pythag? And now you just go to your solver. And you can do it that way too. All right, so just a heads up there. All right, something to think about with the 45, 45. And then what do I got? One more? Oh boy, buckle up. All right, BDC. Everyone find that angle is 45? BDC, 45? Can anybody label that angle 45 for me? B to D to C. It's 45. BAC. Find that angle, 30. BAC, 30. Side BC, 10. All right, find all the other sides now. Okay, let's find all the other sides. Can you help me find in some remaining angles? How about this top angle right here? I got 40. What about this angle right here? CBD.
45.
45, right? Got it? Yep. How about the top angle there, ABC? I got 90 here, 30 here. How about this top angle?
60.
Ooh, 60? Yep. Ooh, how about, yeah. A 45, 45 inside of 30, 60. All right, can we take a look at the 45, 45 now? Gabby, yes.
Would CD be 10?
I got the one with the pen. Can I do the teaching? You done showing off? Okay. Can we start with the 45, 45, 90? I love it though. All right, don't get me wrong. This triangle right here, everyone agrees is 45, 45, 90? What I've been saying all today. The sides across from the 45 are all equal to each other. All right, so now what's the length of DC? 10. Right? What's across from the 45s are always the same. So 10, label your diagram now as 10. How about the hypotenuse in there, BD? If you got to flip back, look at your rule. How do I find the hypotenuse again? I take the leg and multiply it by radical 2. And that's it. You don't have to, I don't want the decimal. So BD, what was the leg again? 10, and just multiply it by radical 2. I don't want the decimal answer. Just leave it like that. I don't want the decimal. Just leave it. 10 radical 2. So we good right now before I move on. So now I've taken care of all the sides in the 45, 45. Can we take care of the sides in the 30, 60 now? Look at the big triangle. This is going to be huge. What side do I already know in that 30, 60, 90? What side do I know one out of the three sides. What side do I know? Emma?
Short side.
Don't I know BC? Everyone, yeah, BC? And look, what angle is it across from? Don't tell me 45. I'm not looking at that triangle anymore. The 10's across from what? 30. So does that make it the shorter or the longer leg? Shorter. All right, I know the shorter now. Where's the longer side? Name it. Where's the longer side of this 30, 60, 90? What side is across from the 60? C, A, right? All right. Go back to your rules today. How do I find the longer leg? I'm just going to write it down right now. How do I find the longer leg? Ooh, longer leg, longer leg. Shorter leg times radical 3. What is the shorter leg again? 10. So it's just going to be 10 radical 3. And how about the hypotenuse? Where's the hypotenuse in that 30, 60, 90? Oh, where is it? Name it. AB, right? All right, go back to your rules at the top of your page. How do you find the hypotenuse in a 30, 60, 90? 2 times the shorter leg. And what's the shorter leg in this diagram again? 10. So it's 2 times 10, 20. All right. Okay, you got to practice though. Got to practice. Hop on Delta Math right now. Got to practice. If you're doing a PyFAG question, just plug it in your solver. Call me over if you need help with the calculator.